Welcome again, man, to the channel, man. Real quick, real freaking quick. I want to go over the typical starter relay. I had a buddy send me a message a couple of days ago. He happened to be working on a PT Cruiser, or 08 PT Cruiser. In this video, we are basically dealing with a 06 through 10 PT Cruiser, but it applies, this diagnostic applies to all cars utilizing a typical ISO starter relay. And that's pretty much most of all of them utilize a starter relay to send power to the starter to allow cranking. Also keep in mind this video is for a no crank complaint, not a no start. So if your car's spinning over, cranking, this video is not for you. We're dealing with a no crank, meaning when you turn the key, nothing happens. You hear absolutely nothing. That is a no crank. We got to get those description and that complaint accurate, so the technician working on it could pretty much have an understanding what you're talking about. So we're dealing with a no crank, all right, and a typical starter relay. All right, we're gonna go over all this diagnostic when we get back. All right, welcome back, man. Welcome back. I want to make this real quick. Like I say to the guy in California, man, I told you, I promise you I'm going to do this. And here we go. We talking about no crank situation on a PT Cruiser. But this diagnostic apply to all cars. So I'm not going to even name the video. Well, I may name it PT Cruiser just to draw in the PT Cruiser crowd, because we basically dealing with a 06 through 10. Only reason I put this, now that car came out in 01, but from 06 to 2010, the electronics changed. So the same theory apply, you know, to the typical starting circuit. All right, let's go over this typical ISO relay, man. You got a pin 30. Pin 30 gonna always be hot. All right, pin 30 gonna always have 12 volts right there on any relay, pretty much. And we're talking about typical ISO relay. ISO International Standard Organization. All right, 86 pretty much gonna be power supply from a switch. In our case, we're going to be dealing with an ignition switch supplying 12 volts switch circuit to the relay. Now, 85 pretty much always coming from, not always, some cars different. Some cars utilize pin 85 differently. But in this case, we getting that ground signal from a controller, or some of them are hardwired ground. But in this case, we getting that ground signal from a computer, PCM. And 87 is actually the load, meaning, you know, it's going to send power to the circuit load in question. In this case, the starter. All right, let's go over these pins. Now, that starter relay on a PT Cruiser is on the firewall, driver side firewall. But you got to be careful because it's right next to the ASD relay. So it's right next to the ASD relay, so you don't want to be diagnosing the wrong relay. Basically, grab both relays. It's on a bracket. Grab both relays. Look for the yellow, gray wire, red, dark blue wire, yellow and tan wire, dark green and the orange wire. But I can show you pretty much what it is right here. All right, we got that out the way. Now let's go to the relay, because this is where the diagnostics come in hand. All right, remember when I said pin 30 got to always be power supply. In this case, Chrysler, in the wiring diagram, they pretty much label it 1, 2, 4, 5, 3. All right, so we're going to do it that way. Pin 1 should be power supply. Now, grab your test light, hook it up to the ground, and see if you got power supply right there. You should. If you do, good. If not, you got more diagnostic to do. Pretty much, pin 1 goes to the relay output inside of the tipper. So if you don't have 12 volts right here, chances are this fuse is blown. And if that fuse is blown, you got other problems, okay? Because fuses don't blow on their own. So you got some diagnostic to do. Pretty much, because this only circuit is on the starter, if this fuse is blown, pretty much you might have a blown or shorted out starter. But you need to do the proper diagnostic to find out if that's the case. All right, let's assume you got 12 volts right here. 12 volts right here, let's move on to the other pin. Pin 2, remember I told you that's the switch power supply circuit. In this case, it's the ignition switch. Now, ignition switch is pretty much on pin 1. So when you turn the key, power supply should switch over to pin 4, which goes to pin 2. Now, if you stick the test light right there on pin 2. If you turn that key, if you're not getting 12 volts right there, again, you may have a blown fuse because that is fed through fuse number 4, which is a little bitty small 10 amp. All right, 10 amp fuse, man. That's all they protecting that circuit with. All right, let's assume when you turn the key, you get 12 volts right there, because that's what you should be getting. Again, if not, you probably got a blown fuse, or open circuit and ignition switch, because let's not leave that out. All right, this is a pink and light blue wire, and that circuit goes through a connector, which is connector 104, and then the wires change color. All these are 16 gauge wires. The wires change color to red and dark blue. So at that relay, the red and dark blue wire should have 12 volts on it as you turn the key on and off. Let's assume it do. Moving right along. Pin number 4, which is basically 87. Remember I told you that's your load circuit. That's going to the load that you wish to turn on. In this case, the starter is the load. All right, now a quick way to check this, verify that this circuit is complete, is to actually physically, manually put 12 volts on pin 4. So take your red wire, it don't have to be red, it could be any kind of wire, one end to a power supply, maybe the battery, and stick that same wire in pin 4. If that starter motor cranks, that circuit is complete. All right. Now, if that starter motor doesn't crank after you put 12 volts right there, there's a couple of issues could be going on, because we got a connector right here, connector 102. It could be open right there. So basically, what I would do is take the brown wire off. Look, as you can see, coming from the relay, the wire is yellow and gray. At this connector, which is connector 102, it changes color to a brown wire. So basically, take the brown wire off the starter. Have someone turn the key, see if you're getting 12 volts on that brown wire. If you is, while you're turning the key, 12 volts, 12 volts, 12 volts, then the circuit is complete. You pretty much got a shorted or open starter motor itself. But keep in mind, we're discussing no crank. So now some starters will play games with you. Some of them will click. As you turn the key, you get a click, click, click. Now, you can pretty much assume that the circuit is complete. You just got a shorted out starter motor. All right. So, but we're not going to assume, we're going to actually do the diagnostic. Now, let's assume this circuit is complete, because you verified. You put 12 volts right here, and a starter motor tried to crank the car. It's spent over. Now, that pretty much means the relay circuit is good. You could either have an open relay, internal short in the relay. So verify that all these pins are doing what they're supposed to do. You should have a ground signal right here at pin 5, which comes from the controller, the PCM. Now you got to be careful with that, because this is a lot of reason why you get no crank. I mean, your circuit can be complete and everything, but if this ground is not there on pin 5, which is basically pin 85, you're not going to start, because you got to have power supply and a ground to energize that coil and cause power supply to go to your load, which is your starter that we're discussing. But if that ground is not there, nothing's going to happen. Now, in this case, this car, most cars looking for inputs in this controller to allow that ground. In PT Cruiser case, we're looking for park or neutral input. There's a couple of inputs it's looking for. The park and the neutral input, meaning your car got to be in either park or neutral to close that circuit and allow ground to go to that starter relay. If it's not, if it's in reverse, that's a safety device. That's to allow or not allow you to crank the car while you're in gear. Just say you in reverse. We don't want you being able to crank the car, because, you know, you might jerk and damage something. So if the car is not in park or neutral, that's one of the inputs, not going to allow the ground to go there. Another one is the security system. That's right, man. The security system, that circuit has to be complete to allow that ground to go over to the starter relay to allow cranking. Now, all these cars, 06 through 10, are equipped with what we call a security system, skim module, a digital electronic key, which basically for theft purposes. Okay, you can't start the car without the proper key. So if you don't have the proper key and you're able to turn the ignition, you're never going to get that ground signal from the PCM, which will allow cranking. So we're going to assume both those inputs are there. You either in park or neutral, and your skim, or your computer is not assuming someone's trying to steal your car. That's another reason why it would take that ground signal away. All right, so we got the whole circuit complete. You're not, now let's use an example. You turn the key, nothing happens. Absolutely nothing happens. First thing, easiest thing to do, I'm a tech, so I can talk to you technician to technician. What I would do would go to this relay, basically, like I said earlier, manually stick 12 volts right here. If the starter spin over, that circuit is good. All right, I will verify I have 12 volts right here on pin 2 as I crank in the car. Yes, I do. I will also verify that I have 12 volts right here. Yes, I do. Basically, one of those pins are open. You're probably not getting ground from here. Like I said, I went over two of the inputs, one being park neutral and the other being a skim module. Okay, so we got to verify. Now, what you can do, pull the wire out of this circuit and manually put a ground wire right there and try to crank the car. If it starts, then yeah, you either got to, I don't like the term bad, you either got a shorted PCM or the inputs are not there. Now, to verify that the inputs are there, you pretty much gonna need a scan tool. Or you can because you can literally be in park or neutral and still not be getting that input. That's why I say a scan tool come in handy for diagnostics like this. Or especially on that skim module, you really gonna need a scan tool to look at the inputs to verify that you're getting the proper input from that skim module to allow cranking, because you're never gonna crank. And that's with any car. If you don't have a ground signal at pin 85 of a typical ISO relay, or pin 5 in this case, you're never gonna crank. You're never gonna crank. You got to have this ground and this power source at pin 1 and 2 as you're cranking, and that's what sends the load over to the starter. Okay, so I pretty much wanted to go over this with you. Verify, man. If your issue is no crank, I would definitely check right here. Basically, I would manually put a ground on pin 5. You don't want to do that with that circuit tied into the PCM. So I would basically move the pin out of it and manually put a ground there and see if it starts. If it starts, then yeah, either the inputs are not there or the PCM is internally shorted. Now, you can't just go grab a used PCM and put in this car. Pretty much any of the new electronically controlled cars, they have to be programmed. But you can use a used PCM. It just has to be programmed. Pretty much by dealer personnel with the proper scan tool that will allow you to do that. Okay, I wanted to keep this video short. So you got a no crank situation. Here's the circuit, man. The ignition switch. You got to have switch power. If you're not getting power right here, check your output of your ignition switch. This is pink and light blue wire. That's a connector on the ignition switch. Verify that at that pink and light blue wire, when you turn the key, you're getting 12 volts right there. If not, you could very well have an open ignition switch, because if power supply is at the ignition switch from the fuse, then yeah, you pretty much have an open. I've seen ignition switch cause a problem with these cars too. So that's it, man. That's a proper way to diagnose a no crank situation on a PC Cruiser, but any car for that matter. Any car utilizing a typical ISO relay to control starter motor. All right, I wanted to keep this video short. Thanks for watching. If you got any more questions, man, ask them on the page, the actual YouTube page, because I monitor that all the time. You know, that Facebook page, I'm not on as much as I'm on the YouTube page, but comment, subscribe. I need some more subscribers, and I'll see you on the next video, man. Thanks for watching.